Hi everyone, this is 3.4 and today we're going to talk about a graph's intercepts. And before we do that, let's talk about the x and y axis. So when you're plotting points in what we call a coordinate plane, you always start with the x-axis and the y-axis. So basically here's a quick picture. The pink one on the left is the x-axis. That's that horizontal line going across the middle. And we call it the x-axis because that's where you count x's. X always goes left and right, so you're counting the x value across that pink line. Positive would be to the right, negative to the left. Then on the right side you have the y-axis in yellow, and that's called the y-axis because that's where you count the y's. Y goes up and down. So for a positive number you count up, and for a negative number you count down. So the x and y-axis make up what we call the coordinate plane, and that's what we plot points or draw graphs in. Now the reason that's important, because the intercepts of a graph, well basically the word intercept means to cross. So an intercept is where a graph crosses either of those two lines. An intercept can happen where you cross the x-axis or the y-axis. And then to tell the name of each one, we just put that letter in front of it. So the x-intercept is wherever a graph crosses the x-axis. And the y-intercept is wherever it crosses the y-axis. So here's a very simple graph. This is a line, and you can see the line is kind of going across diagonally there. The red point where it crosses the y-axis, that's what we call the y-intercept. The green point where it crosses the x-axis, that's what we call the x-intercept. And you can do this with any graph at all. So let's say, for example, I'll draw a quick sketch of another graph here. Let's say we had one that wasn't linear, was a little bit more complicated. Let's say we have a graph that looks like this. This graph that I just drew actually has 3 x-intercepts. You can have more than one x-intercept. So the graph crossed the x-axis right here, and right here. All 3 of those red points are x-intercepts. Now there's only one y-intercept, and that's right here, the yellow point. So you can see it's a real simple concept. You draw the graph, you look at it, wherever it crosses that horizontal line in the middle that we call the x-axis, we call that an x-intercept. Wherever it crosses that vertical line in the middle that we call the y-axis is the y-intercept. Now, a good thing to remember about intercepts, each intercept happens whenever the other thing equals 0. So the x-intercept happens when y equals 0, and the y-intercept happens when x equals 0. Because when each one is 0, you're on the axis. Like for example, if y equals 0, y is how far you go up or down. If you haven't gone up or down at all, you're right in the middle, you're on the x-axis. And same thing if you flip it around. X is left and right. If x equals 0, you haven't gone left or right. You're right there in the middle on the axis. Now because of this, we sometimes call the x-intercept of functions 0 or zeros. And you're going to see that word in the homework tonight in at least one problem. It's going to say, tell me about the zeros of this function or the 0 of this function. Just know what you're basically saying is the function itself is basically y, because functions are usually y equals. So y represents the function. If you're talking about a function zeros, you're talking about where y equals 0. And like we said above, where y equals 0 is the x-intercept. So let's wrap it up with this example right here. I said, I graphed this is called a parabola or a curve. And I said this picture below represents a football being thrown. What does each intercept represent? Now, the x and y axis in this picture, if you look carefully at the numbers, this is 0 down here. That means the x and y-axis, I'll draw them in purple to make them stand out. This is the y-axis right here, and this is the x-axis right here. So let's do one at a time. Let's start with the x-intercept, which would basically be this point right here that I just highlighted in red. That's the point where the graph crosses the x-axis. So if I look very carefully, the x-axis is being counted by tens. It goes 10, 20, 30, 40, 50. So that point is in between 40 and 50. Looks like it's a little closer to 50. I might approximate it as about 47. But remember, for the x-intercept, I'm not just going to say the number 47, because the x-intercept is a point. And that point is actually 47, 0. It's positive 47, because I went 47 to the right, and it's 0. It's not up or down. And remember, we said the x-intercept happens when y equals 0. So y is always 0 when you're doing x-intercepts. A point 47 spots to the right would be the point 47, 0. Now what's more important, I didn't ask you what the x-intercept was. I asked it what it represents. So if you look at the parabola, what's basically happening here, you have this football that's starting about here. Somebody throws it, it's going up, coming back down, and that x-intercept probably represents where the point where the football hits the ground. So that's what I would say. I asked you, what does the intercept represent? The x-intercept represents where the football hit the ground after he threw it. And we don't really know what we're measuring in, maybe yards. Football is measured like a football field's 100 yards. So maybe we'll say that. The guy threw the football and it landed, it hit the field, it hit the ground 47 yards downfield. Okay, now for part 2 of this question, let's figure out the y-intercept, which would be this point right here. So that light blue point that I just drew, that's the y-intercept, that's where it crosses the y-axis. So let's do that over here, y-intercept. Now, when you're throwing the football, notice the y-intercept was up. It looks like we're counting by 2's, so it's a little bit more than 2. Let's say it's about 2.3. I'm going to guess that's about 2.3. And I'm approximating. If you said 2.2, that's fine. Now that is the point 0, 2.3. Because again, x is 0. The y-intercept doesn't go to the right or to the left. It's right there in the middle. It's over nothing, up about 2.3. It's a little bit more than 2. But what's more important is, let's see what it represents. Well, what it represents is where the football is starting. See, when you're throwing a football, some people might have drawn the picture like this. They might have said, okay, well, let's say we're throwing a football. It's going to start right here, it's going to go up, and then it's going to come down and hit the ground. Well, the problem is that's not realistic, because then the football is starting on the ground, going up and landing on the ground. Well, when somebody throws a football, they don't throw it from the ground, they throw it from above their head. They throw it from up here. So probably what would be better, what's happening here is you have this quarterback who's standing right here, but he's throwing the ball, he's holding the ball up like this. He's holding the ball above his head. And all of a sudden that number makes sense, because 2.3, if remember we said we're probably measuring in yards, 2 yards is about 3 feet. 1 yard is about 3 feet, so 2 yards is about 6 feet. So it's perfectly normal to say a football quarterback might be about 6 feet tall, but he throws the ball from above his head up here, so that extra 0.2 or 0.3 yards is where he's letting go of the ball. So that's how I would describe the y-intercept. I would say the y-intercept represents the point where the quarterback let go of the football when he was throwing it. And in this problem, it's about 2.3 yards above the ground. Maybe the quarterback is 2 yards tall, and the ball was up here above his head when he threw it. So now all of a sudden you have this realistic representation of the y-intercepts. This quarterback is probably about 6 feet tall, about 2 yards tall. He threw the ball from a little bit over his head up here. The ball then went up, came back down to the ground, 47 yards downfield. Now the one thing is, I got this picture off Desmos, so it's just a graph, and the graph itself kind of kept going through the ground. That's not very realistic. Realistically, what would have happened is the ball would have bounced and kept going this way. But you get the idea. So basically what we did is we took a word problem with a picture, we checked the x and y intercepts, but instead of me just asking you what are they and you looking at them and telling me a number, I asked you what they meant in the problem, and that's an important concept for what we're going to be doing today.